In lesson 4.2, we will apply the angle sum theorem and apply the exterior angle theorem, learning about angles of triangles. The angle sum theorem, theorem 4.1, states that the sum of the measures of the angles of a triangle is 180 degrees. So in their triangle, the measure of angle W plus the measure of angle X plus the measure of angle Y equals 180. And the reason this is a theorem is because it can be proved using other theorems and postulates. And they have a proof of that on the bottom of page 185 if you're really interested, but I wasn't going to take the time to go through it because we have known that there's 180 degrees in a triangle for a very long time. So example 1 takes what we've done in earlier classes one more step. We have found one missing angle in a triangle before, so we'll start with angle 1. So we know if we take 74 plus 43, we get the sum of the other two angles is going to be 117. So if we subtract 180 minus 117, we get the measure of angle 1 must be 63 degrees. And then we can see in the diagram that angle 1 and angle 2 are vertical angles, so their measures must be the same. So angle 2 is also 63 degrees. And then we can use that to find angle 3. So we're going to add 79 plus 63 would be 142, and then if we subtract that from 180, we get 38 must be the measure of angle 3. Those are 3 answers for one problem. Theorem 4.2 is a third angle theorem. If two angles of one triangle are congruent to two angles of the second triangle, then the third angles of the triangles must be congruent. So in their diagrams, if angle A is congruent to angle F, and angle C, with 2 marks, is congruent to angle D, because there's only 180 degrees in a triangle, all that's left, angle B must be congruent to angle E. Each angle of a triangle has an exterior angle. An exterior angle is formed by one side of the triangle and the extension of the other side. The interior angles of the triangle not adjacent to the given exterior angles are called the remote interior angles of each exterior angle. Now that we know what an exterior angle is, the measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. So in this diagram, the measure of angle YZP equals the measure of angle X plus the measure of angle Y. So far we've looked at paragraph proofs and two-column proofs. We'll use a flow proof to prove this next theorem. A flow proof organizes a series of statements in logical order, starting with the given statements. Each statement is written in a box, with a reason justifying the statement written in the box below. Arrows are used to indicate how the statements relate to each other. The book has an example of a flow proof to prove the exterior angle theorem. So they gave us triangle ABC, and they wanted us to prove that the measure of angle CBD equals the sum of the measures of angle A and angle C. Just like with our other types of proofs, we're going to start off with the given, but also from the diagram, they said, hey, angle CBD and angle ABC form a linear pair. That doesn't necessarily come off from the given, so they didn't draw a triangle there. They drew a line from triangle ABC to the fact that the sum of the three angles is 180, and then the reason is here underneath the box, angle sum theorem. Okay, from our linear pair line of thought, they justify that saying this definition of linear pair, and then CBD and angle ABC must be supplementary because if two angles form a linear pair, they must be supplementary. And we know that supplementary angles add up to 180, so they wrote that. Measure of angle CBD plus measure of ABC equals 180. Now, both of these lines of reasoning flow into this next one. So measure of angle A plus measure of angle ABC plus measure of angle C equals measure of angle CBD plus measure of angle ABC by substitution. If they both equal 180, they must be equal to each other, right? So then they could subtract the like things from both sides, which in this case was the angle ABCs, and they ended up with measure of angle A plus measure of angle C equals the measure of angle CBD, and the reason was subtraction. And that's what we were trying to get to in the two proofs, so we know we have arrived and we are there. For example 2, they ask us to find the measure of each numbered angle in the figure. Now I can see that angle 1 is exterior to these two, so the measure of angle 1 is going to be found by adding 32 plus 38. So I get my sum at 70 for 1. I'm going to write that on there. Keep track of what we know. Okay, now that I know angle 1 is 70, angle 2 is supplementary to that. So the measure of angle 2 must be 180 minus 70, so it must be 110. Which is believable, it's an obtuse angle. Now I can see angle 2 is an exterior angle to these two interior angles here. So to find a measure of angle 3, I need to subtract 110 minus 64. I could have set it out as an algebraic equation too, I suppose, but I didn't. Okay, so measure of angle 3 should be 46. Now to find angle 4, I can see that angle 3, which we just said was 46, plus 32 plus angle 4 has to equal 180. So to get measure of angle 4, I need to take 180 minus 46 plus 32. So we have 180 minus 78 is 102 for angle 4. And now for the measure of angle 5, that's the third angle of that triangle. So I'm going to take 180 minus angle 4 was 102, and the 41 that's already there. So I have 180 minus 143. I guess don't need that parenthesis, but it's there now. So I get 37 degrees for angle 5. We've talked about postulates as statements that are so basic they can't be proven. Theorems are statements that can be proven from postulates and other theorems. A statement that can be easily proved by using a theorem is often called a corollary of that theorem. A corollary, just like a theorem, can be used as a reason in a proof. Corollary 4.1 states that the acute angles of a right triangle are complementary. And theorem 4.2 states there can be at most one right or obtuse angle in a triangle. For our last example, the flower bed is shown in the shape of a right triangle. Find the measure of angle A if the measure of angle C is 20. From that corollary 4.1, we know that all we have to do now to find angle A is subtract 90, which is all I have left for the other two angles, other than the right angle, minus 20, and I get 70 degrees. So summing it all up, the sum of the measures of the angles of a triangle is always 180 degrees, and the measure of an exterior angle is equal to the sum of the measures of the two remote interior angles.